All right, our next and final example here is a problem that we're going to have to use integration by parts repeatedly to solve this. So we have this example. It's the integrand is x squared e to the x. All right. So again, I have to kind of decide what's u and what's dv, and I can think of that Lie8 again. Logarithmic part, there's no logarithmic part. Inverse trig part, no inverse trig part. Algebraic part, we do have an algebraic part. So I'm going to let u equal x squared, and again dv is e to the x dx. Alright, so dv just encompasses everything that's left. So what's the next step here? Well, I have to find du and v. So derivative of x squared is 2x, so du is 2x dx. And dv, the antiderivative of e to the x, is just e to the x. Right, so I put those into the formula for integration by parts. And integral of u dv equals uv minus integral of v du. And I can see that the new integral that I have to deal with now is this. I factor the 2 out here. Right? So if I look carefully at that, I can see that it's simpler than the original integrand, which is a good thing. I've made some progress. And if you look carefully about how it's simpler, I started off with an x squared, and now I just have an x to the first power. So I've effectively, the e to the x dx part is the same, but I've reduced the power of x by 1. Right? Now you might be able to anticipate if I could reduce the power of x again, then I'm just going to have e to the x dx, which is really easy to integrate. Right? That e to the x dx part, if it follows this pattern again, then we're just going to have another e to the x, but if I reduce this one more time, then we're going to have e to the x dx. It's easy to integrate from there, find the antiderivative of it. So I'm going to work just on this integral. I'm going to work just on this integral of x e to the x dx, and I'm going to use integration by parts again. Okay, so part of our answer is this x squared e to the x minus 2 times what we're going to work on now. So we can't forget about that, but for now I'm just going to work on this integral here. And I'm going to kind of go through the same process. It's an integration by parts. I'm going to let u equal the algebraic part, the x, and then e to the x dx is the dv. As soon as I find u and dv, I have to then find du and v, so I differentiate u and I integrate or find the antiderivative for dv. And then I'm left with this now. So that last part of my original answer up here has now become u times v minus the integral of v du. And now this is very easy to integrate. It's just a simple antiderivative. In fact, it's just the e to the x itself. So you see that I reduced the power of x in the integral one more time. And now I can take this and put this back into this part here that was multiplied by the 2. Remember, after my first round of integration by parts, I was left with this expression. Now I know what that is. It's x e to the x minus e to the x plus c. And then I distribute that negative 2, multiply that through by everything inside the parentheses, and I have my final answer there.